Welcome to Martin's Institute of Teaching. In this video, we're going to be dealing with signed binary numbers, and this is part 3 on a series of binary numbers. So, in the first video, in the first part of the series, I showed you how to deal with binary numbers, how to convert them to decimal, and how they work. So, in the second video, we also dealt with adding binary numbers together. So now in this third video, we're going to deal with negative numbers or subtracting. Now, the problem that you run into when you're dealing with binary numbers is, well, how do you represent them? And what we know is that computers, they only deal with 1's and 0's. So when you have a negative, that's a problem because all computers, they either have a 0 or a 1. 0 indicating nothing, no voltage, and a 1 having a switch registered to 1 or assign the value of 1 for that it actually has charge or that it is powered up. So all of a sudden when you have a negative, you would need a third, like a third bit in order to, or something that says that it's negative. But how do we say something is negative? Well, that's where signed numbers come into play. Before we had unsigned numbers, and they were all positive. But now with the signed numbers, now we will have negative numbers. Now, when we have negative numbers, we're gonna have to find a way to show that they're negative. So before, when you had unsigned binary numbers, you had a number like, let's say 1, 2, 3, and this 3-bit binary number, unsigned binary number, well, this would be the equivalent of 7. Now, let's say we're only going to use 3 bits. Well, but we want to make a negative number. Well, the problem is, how do we tell the computer that this is a negative number? Normally, the way we would tell in decimal, we would say, well, if this is a negative, we just put the negative sign in front of it, and it's negative. Now, for computers, they don't have the negative. They only have 1's and 0's. So what they ended up doing was, to show that a value is negative, they said, okay, well, we're going to designate this first value here. If it is a 0, then it is positive. If it's a 1, well, then it's negative. So if I have this value here, if I'm only dealing with 3 bits, the most significant bit, which is the leftmost number, that will indicate whether it's negative or positive. Here I have a 1. So this value is telling me that this 3-bit number, this is a negative value. So this right here, this most significant bit, will tell you that it's negative. If instead I had a number like, let's say, if I had 0, 1, 1, this indicates that it's a positive number. So this would be negative, and this one would be a positive number. So when they were first coming up with this, they had a problem because they said, okay, well, we'll just say this first value will tell you if it's negative or positive. Well, and they said, okay, let's run with that. So they said, if we want to have, let's say, here's the value 3. Now I want to have a negative 3. Okay, well, and they said, okay, how about this? This should be negative 3, right? Because 1, this first value is just a 1, and this second value represents a 2. So 2 plus 1 would be 3, and this most significant bit represents a negative. So this should be negative 3. And so I said, okay, great. Well, to test this out, if we add negative 3 and positive 3 together, we should get a 0. So then they tested it by taking these two values. So they said, okay, 1, 1, 1, and they're going to add it to plus 0, 1, 1. So when they add these together, they should just get 0. So they said 1 plus 1, that's a 1 with the 1 carry. 1 plus 1 is a 0 with the 1 carry, plus a 1 makes another 1. So we get that, and then we get 0, and 1 is a carry. Well, this is not 0. So when they did this, they realized, well, in binary, adding negative 3, and if this is negative 3 and this is positive 3, well, then that doesn't work out. It's wrong. So what do we do? Well, that's when they came up with something called 1's complement. It's also known as a NOT operation, and the way it works is, if you have a value like, let's say, 0, 1, 1, well, you convert this to 1's complement by just flipping everything. So the first value, actually, let's scroll down a bit. So this least significant bit, that would be converted into a 0. The second bit would be converted into a 0, and this most significant bit would be converted into a 1. 1, 0, 0. And then let's see, so that's how they would do it. So if you had another number like, let's say 1, 1, 0, 0, you would do the ones complement of this by just flipping everything. So this one would in turn be 1, 1, 0, 0. And that's what ones complement is. And after that they came up with another, and this is what they currently use, it's 2's complement. Because ones complement has the problem of when you're dealing with certain numbers that they just don't work out right. And I could go into that, but really there's no point because it doesn't really matter. Instead we're going to go straight into 2's complement because that's what actually does matter. So 2's complement is basically the exact same thing as 1's complement, except you add a 1 at the end. So if I have the value of 0, 0, 1, and I'm changing this to 2's complement, this gets turned into a 0, this is a 1, and a 1. And so this is the first part, and the second part is you add plus 1 to it. So then you would get 1, 1, 1. And the 2's complement of 0, 0, 1 is 1, 1, 1. Okay, so let's see. And another important part of this is that usually when you're dealing with, well, always when you're dealing with computers, you're going to have a certain number of bits you're going to be working with. So, and that's it. So if we're dealing with, let's say, 4 bits, then this one will always indicate whether it's positive or negative. And if you're dealing with any two numbers, if this number, well, okay, you know what, let's get straight into it and I'll show you a couple of examples. So first off, let's go ahead, this will be our first one. Let's do, let us convert. Let's say we want to get the number 5, and we want to get its 2's complement version, because if this is like 5 is 1, 0, 1, this is a 3-bit unsigned binary number, and this represents 5. Now if we have in order to do 5 in 2's complement with signed numbers, you're actually going to need 4 bits. So having 3 bits will not work with 2 signed if the number requires more than 2 bits. So let's say we wanted to do 5. So in 5, using unsigned numbers, you would need a 4th bit. So we're going to say 0, 1, 0, 1. This is 5 in decimal. This is signed. This is a signed binary number. And that's it. It's a signed binary number. If you have unsigned, then you could go ahead and just use 3. But if you're using signed, then this first value indicates if it's positive or negative. So that's positive. And now if we want to convert this to -5, well, the way we do it is we go ahead and flip all the numbers. So it would be 0, 1, 1, 0. And then we add plus 1 to it. So all of a sudden we're going to end up with 1, 0, 1, 1. So this is the equivalent of -5. And if we add this and 5 together, then we should go ahead and get a 0. So if we get 0, 1, 0, 1, that is plus 5. And we're going to add that to -5, which is 1, 0, 1, 1. If we add these two together, we should get 0. So 1 plus 1 is a 0 and a 1. 1 plus 1 is a 0 and a 1. 1 plus 1 is a 0 and a 1. 1 plus 1 is a 0 and 1 for the carry, which it just gets thrown out because you're only dealing with 4 bits. So it does turn out to be 0 in the end. So let's see. Let's go ahead and do another example. So let's say we have this value. And a good way to check these out is after you work them out, just go ahead and pop them into some converter and see if you get the right value. Let's say we have the value of 7. So 7, when it's unsigned, it would just be this. But if it's signed, it has to be 4 bits. So this would be +7. And if we're going to convert this to a -7, we need to get its 2's complement version. So In order to do that, first thing we do is convert this. So let's go ahead and flip everything. That's the first part. The second part is adding plus 1. So you get 1, 0, 0, 1. And 1, 0, 0, 1 is negative 7 in, well, it's negative 7 in signed 2's complement. So if we got, let's say, so if this is 7, actually this is negative 7. So if we, let's just for an example, let's say negative 7 plus 2. If we get this, we should get a value of 5. So let's test this out. So here we're saying that this value here is negative 7. So let's test it. Let's say 1, 0, 0, 1 plus 2. And 2 is represented by 0, 0, 1, 0. That would be the equivalent of a plus 2. And if we add this, we should get 5. And let's see if that's what we get. Oh, wait a minute. Did I miss something? I don't think so. Let's see, converted this, added 1, okay, and then that's 2. Well, it should be, actually this should be negative 5, because negative 7 plus 2 is negative 5. So we go ahead and add this, so add 1 to there, 1, 0, and 1. This first part indicates that it's negative. Now, you might be looking at this and say, well, that's 2 and that's a 1, so this is only 3. But when you're dealing with, this is negative 5 in 2's complement. So the problem with that is that when you get a value that's a negative in 2's complement, you have to convert it back into binary. Well, back into not. You have to convert it back to its positive version. So the way we do that is we take the 2's complement of it in order to find out what the actual value is. So we go ahead and initially convert everything back. So that's a 0, 1, 0, 0. And then we add 1 to it. So you get 0, 1, 0, 1. And it turns out to be 5. Because this one is 1 and this one represents 4. So we actually do get 5. If we take the 2's complement of this to find out what it is. Now you might be wondering, I know initially when I first learned this, I got a bit confused about when to take the 2's complement. And when you always take the 2's complement, like let's say we looked at this value here, and you looked at it and you're like, well, this doesn't look like 3 at all. Or it doesn't look like 5 at all. Or negative 5. It looks like negative 3 to me. And you might say, well, because in the previous videos, you took this first value and you said, okay, that's 1 times 2 to the 0 power. Plus, and then you had this one, so that's 1 times 2 to the first. And that's 2, and that's 1. So 2 plus 1 is 3, negative 3. And yeah, I know that's what we did when they were unsigned. But these are signed values. And when you have a signed value, you can't do it this way. Well, not totally. There's actually a step that you need to do. So when you look at this, it's signed, and that changes everything. So when you deal with signed values, in order to find out what the value actually is, you have to convert it with 2's complement. And that'll give you what the value is in decimal. Or I'm sorry, that'll give you what the value is unsigned. And then you just have to remember that it came from a negative, and really that's what the value is. So let's go ahead and do another example of these, because I think it's easier just to see it than it is to just talk about it. So let's go ahead and, oh, I need more space. Okay, so now let's go ahead and deal with, let's say we're dealing with, let's see, what value? Let's deal with 10. So 10, and we're going to do, let's say minus, let's do minus 5. So now, if we're going to do this value, we would get a plus 5. So here I'm dealing with the positive 10. Now positive 10 is what? Let's see, so 1, 2, 4, 8. So if I wanted to do 10, I'd have a 1, 0, 1, 0. Which I require 4 bits. So since this is going to be signed, I need 5 bits in order to do this properly. So 10 is going to be the same as saying 0, 1, 0, 1, 0. That is plus 10. So now we want to do negative 5. So negative 5, first off, we start off with 5, which is just 1, 0, 1. But we need to get its 2's complement in order to get it into a negative form. This is plus 5, but I need 4 bits, so I need to add another bit here. So this is my negative. This is the one that will say whether it's a positive or negative. It's positive here because first I'm dealing with plus 5, and I want to get its 2's complement. So I'm adding this extra 0 in order to indicate whether it's positive or negative. Right now it's 0 to indicate this is plus 5. But now I want to switch it over to negative 5. So let's go ahead and switch these. Get 1, 1, 0, 1, 0, plus 1. So we get 1, 1, 0, 1, 1. And this represents negative 5. This is plus 5, and it's been converted down into negative 5. This is plus 10. So then we're just going to add this other value to it. So let's go 1, 1, 0, 1, 1. Now, when we add these two values together, so this is plus minus 5. Okay, so when we add these two values together, 10 plus negative 5, we should get plus 5. So let's go ahead and do that. So we get 0 plus 1 is 1. 1 plus 1 is 0 with the 1 carry, and then we get 1 here. 1 plus 1 is 0 with the 1 carry. 1 plus 1 turns this to 0, and the 1 carry, which just goes away because we're only dealing with these values here. So as you can see, when we add 10 plus negative 5, we end up getting 0, 0, 1, 0, 1, which this is our number, and this tells us if it's positive or negative. Since we said 10 plus negative 5, we ended up getting plus 5. And this one just tells you it's positive, and then says it's 5. So that worked out pretty well. So maybe we do another example. So that's 3 examples. One more can't hurt. So this is example number 4, dealing with 2's complement, subtracting and adding. So let's see. Now what happens when we add, let's say, negative 5 plus negative 7? Well, first thing in order to do this, we need to find negative 5, the 2's complement version of negative 5. So first we're going to take the positive version of 5, which is written as 0, 1, 0, 1. And then we're going to take the positive version of 7, which is 0, 1, 2, 3. Oh, actually, no, I'm going to need more space. First, let's convert 5 to the 2's complement, and then we'll convert 7. So converting this one, we flip everything. So you get 1, 0, 1, 0, add plus 1, then you get 1, 0, 1, 1. And this is equal to negative 5. Now we're going to deal with 7. So we're going to say 7. And that's the same thing as saying 0, 1, 1, 1. We're going to flip everything. So we're going to get 1, 0, 0, 0, plus 1. So negative 7 will be 1, 0, 0, 1. And that'll be equal to negative 7. So if we add negative 5 and negative 7, we should get negative 12. Now, to get negative 12, we need at least 4 bits. So this isn't going to work out so well because we only have 4 bits here. And in order to do negative 12, we need an 8 and a 4, and we'd need another bit here. So it would have to be, this represents plus 12, but we wanted it in negative 12. So we're going to need at least 5 bits. So when we deal with 5 bits, we're going to have to start off with 5 bits. So let's just, let's see, you know what, it's no problem. So if I add a 0 here, then that one gets flipped and becomes a 1 here. Since nothing gets added to it, it just stays like that. So this represents negative 5. 7, so this was 7 with 4 bits. Now we're going to have to add another 0 here. That still represents positive 7. That one will be a plus 1. So we'd have 1. So this would be negative 7 with 5 bits. So let's go ahead and add these two values together. If this is negative 7 and this is negative 5, if we add those both together, we should get negative 12. So here's negative 5, 1, 1, 0, 1, 1. plus 1, 1, 0, 0, 1. So if we add these together, we get 1 plus 1 is 1. That's a 0 with the carry. 1 plus 1 is another 0 with a carry. Then we get a 1. 1 plus 1 is 0 with a carry. 1 plus 1 is a 1 with a carry. So now this is our 2's complement version of negative 12. But now I want to convert this just to be certain that this really is negative 12. So let's go ahead and check that out. So in order to convert this, we need to flip everything and add 1. So let's go ahead and flip this. So this would be 0, this would be 1, 0, 1, 1. We're going to add plus 1. And this hopefully should end up being 12. So 1 plus 1 is 0 with the 1 carry. 1 plus 1 is a 0 with the 1 carry. You get a 1, 1, 0. Now if we convert this to decimal, this first one would be a 1. Actually it's a 0 because 0, 0, another 0, but that's 1, 2, 4, 8, 0. So adding these together, we would get is equal to 12. So it turns out that this value is correct. This is negative 12. Its 2's complement is this, which is plus 12, and that is correct. So, okay, so I think these are still a bit confusing, so I'm going to do a few more videos on these. Well, yeah, let me know. If you guys want more videos on this, just shoot me an email, or actually just add it in the comments. I'll make a few more videos on this topic. If not, I'm just going to move on. So let me know. I'll give you guys about a week or so. Yeah, so I hope this video helped you out. If it did, great. Don't forget to click like and subscribe. So good luck in your classes.